Hello RB, we want to go through the rules for integration, just a quick summary of what we were doing before. So we start off just reminding ourselves of the rules for differentiation. So when we're differentiating a constant, then we get a 0 if we have a term in x with some constant out the front of it, some coefficient. When we differentiate that, we just get left with the m, and then the other constants become 0. Remember our rule for x to the n. When we differentiate it, we're going n to the minus 1 multiplied by n, etc. So we've got adding terms, we've got a product rule, we have a quotient rule, then we've got the chain rule. When we're doing integration, it's the opposite. We're undoing, we're anti-differentiating, we're going back from the derivative back to an original function or the primitive function. So if we have a 0, then there must have been a constant. If we have a constant number, then it must have come from a term in x. If we've got some power of n, then to go backwards, we're undoing the minus 1 by going plus 1, and we divide by the new power. If we've got a function, and that becomes a derivative, then the inverse, not the inverse, the antiderivative takes us back to the original function. If we're adding functions, then we can just simply integrate each of those functions individually. So if we've got x squared plus x, it goes back to x cubed on 3 plus x squared over 2. So hopefully this is familiar and you haven't forgotten all these. As far as the product and quotient rule, there's no rule as such for those. In integration, we're going to look at doing that with integration by substitution, which we'll do later. Again, with the chain rule, there's some types of functions we can do with a type of chain rule, but again, we'll look at those in more detail. E to the x we can do when we differentiate e to the x, we get e to the x, and vice versa with the anti-differentiation. Where we've got a function, we're going to have to look at that one. That's a little bit different. We've got our log function, goes to 1 on x, so our anti-differentiation is going to take us back. A function of that, we're going to look at those. So we're going to look at all of these in this section as we go through. So let's just go back to that polynomial rule. If we have x to the n and we want the integral with respect to x, then we get x to the n plus 1, divide by n plus 1, plus the constant. Shift this over a little bit. So it's only when we've got a power on an x. The domain for n, we can have any values for n except when n is minus 1. Because if we go minus 1 plus 1 gives us 0, that's okay. But minus 1 plus 1 gives us 0 in a denominator is not okay. So we can't use that rule when we've got f, our function is 1 on x. If it's 1 on x squared, we're okay, but not 1 on x. So our integral of 5 dx, we've got a constant, so that must have been 5x plus c, our constant. If we've got x cubed, there's that power of 3, we're going to add 1 to it, divide by the new power of 4 to get x to the 4th plus our constant. If we've got a mixture of terms in x that are multiplied, and they're both just x's, first job is to make them as 1 power. So remember that x is the same as power of 1, root x is a half, 1 plus a half is 3 on 2. So now we can just do our rule by adding 1 to our power, makes 5 on 2, divide by the new index, plus constant, and then tidy it up to make it look neater. Bring our fraction in the denominator up so it's 2 over 5, and then turn this back into root x's. This is acceptable as your final answer in an IB exam. This is just sort of making it nice to turn it back into how we got it. We started with a root x, and it's nice to finish with a root x. Here, 1 on root x, same story. Turn it into a power. So we've got x to the minus a half. Square root is a half. On the denominator makes it minus a half. Integrate that. So we add 1 to the power, makes plus a half. Divide by a half. plus c, and then do our tidying up. So we get divide by a half is the same as times 2, x to the half is root x. We are going through quickly here. If these are problems, then you need to stop and take time to look at them, think it through, and come and see your teacher if you're not sure. All right. So the overall rules for our anti-differentiation, constant goes to kx, x to the n plus 1. So these rules are just summarised from the textbook here. So nothing new with those. That's what we were working with on the previous screen. Let's look at our other functions that we've done through the course. Let's look at what happens when we have n equal to -1. In other words, we have 1 over root x, or x to the -1. We remember that when we differentiated a log function, we get 1 on x. So when we think of our log function, and if we're differentiating, we're talking about looking at the tangents to a curve. So what happens to the tangents to this curve as we go along? It starts off steep and gets less steep and less steep. Here, the function here of y equal to 1 on x is describing that pattern. Really high value, very steep, then getting less steep, less steep, less steep, which is what happens. So that's what happens when we differentiate the log of x, gives us 1 on x. The integral, remember, talks about the area under the curve. So the area under the curve of 1 on x can be calculated from the rule of y equal ln of x, the natural log of x. So this area can be calculated from the log function. Note this is log base e. It's never log base 10 when we're doing integration. And we always have to make sure that our x's are positive because we can't put a negative in here. So we want to put the absolute value signs in there to ensure that we only have positive x values. So that's our domain for x is greater than 0. We can't even put 0 into here because there's no value, it's an asymptote. So that's our integral for 1 on x. The next one that we've done was e to the x. Remember, if we have that function and differentiate it, we get e to the x as well. So the integral of e to the x dx is also equal to e to the x plus a constant. So that one's a nice simple one. We're just looking at x's in here. We're not looking at functions in there. We'll look at that, make it a bit more complicated later. Next one are our trig functions. Do you remember when we differentiated sine, we get cos? So if we differentiate, we get cos. So in other words, the integral of cos x dx gives us sine x. So our antiderivative of cos x is sine x and then plus c. When we differentiated cos, we get minus sine. So that's our differentiation. So if we integrate sine x dx, then we're going to end up with minus cos x plus our constant. So differentiating sine to cos, both are positive. Integral of cos back to sine, both positive. Here, differentiate cos, you get minus sine. So when we integrate sine x, we come back to minus cos x. So they're in your formula booklet, but you do need to remember those. All right, so let's put this all together and do a whole lot of combinations. Here's our integral of 3 different terms. We can treat them separately. So integral of 1 over 2x, that's the same, remember, as a half times the integral of 1 on x. So in other words, this part here, we can take that out, needing a 1 here, of course. We can take that out, the front of the integral, it won't change that integral. So that half comes out the front, so we get half times the integral of 1 on x, we get half ln of root x. If you wanted to, you put the half inside your log, remember your log rules, to give the log of root x. And let me just shift this over. And now 0, x is greater than or equal to 0. And then taking the other terms here, integral of x squared becomes x cubed, the power of 3, and then divide by 3, minus integral of e to the x is e to the x, and then don't forget the plus c at the end. Next one, if you didn't do this in class, you could always stop and have a go at it and then check your answer. So we want the integral with respect to x of x squared times root x minus 10x. They're multiplied, so it's not really a product rule. Let's put it together as a power on x. So if x squared, that's the same as, let's come over here, remember that x squared equals x to the 4 on 2. And then we've got x to the half. So you should remember these by now. Get used to working in fractions. So that means we've got x to the 5 on 2 minus 10x. Don't forget here your brackets. When you're writing this, we want everything differentiated with respect to x. So put your brackets in dx. That's important. So now we're going to add 1 to our power and divide by the new power. And then the integral of minus sine x, remember, is cos x. So x to the 7 over 2, divide by 7 on 2, minus 10, you could just leave that as it is. Integral of sine x is minus cos x. So that now makes plus. Tidy this up, bring your divide by 7 over 2 means multiplied by 2 on 7. And then remember 7 on 2 is the same as 6 on 2 and a half, 1 on 2. So 6 on 2 would become x cubed times root x. So again, if you've got problems with your indices and fractions, take time to go through them, otherwise come and chat to your teacher. Next one here, remember we said there's no product or quotient rule, so you've either got to expand or do your dividing. So here we've got a function, this is more like a chain rule, you could have differentiated this with a chain rule, but here you need to expand it out, so use your FOIL to expand 3x plus 2 on x, so you end up with 9x squared plus 12 plus 4 over x squared. Think of x squared as x to the minus 2, integrate that now, so up goes the power of 2 to 3, so 2 plus 1 is 3, divide by 3, and the 3's cancel. 12 becomes 12x, add 1 to the power, gets minus 1, divide by minus 1, plus your constant. Tidy it all up, so bring your x down, make that your negative, and you've got your nice answer there. The next one here looks like a quotient rule, but don't, just split it into 2 fractions. So we get 2x over root x minus 1 over root x. Rewrite them all with powers of x. So every time, turn it into a power of x. All right, so that's to the minus a half because it's in the denominator. This is to the plus 1 in the numerator. So the net result is x to the half. This here is 1 over root x, so it's minus 1/2. Add your power of 1 to give 3 on 2, divide by 3 on 2, which is the same as times 2/3. Here, add 1 makes plus 1/2, divide by 1/2, which is the same as multiplying by 2. Tidy it up and make it look like how you started, and we come out with our final answer there. So hopefully you've had a chance, or if not, have a look at E.1, and then in class we'll start up with E.2 and go through how we can actually get values for that constant. Thanks for listening, IB. Looking forward to seeing you in class.